Started. Again, welcome to our conference. We're going to start off with an overview around large language models, generative AI, and AI agents, tell you a little bit about the space. This is kind of more of a talk which is geared to people who are fairly new to the space, who want to understand kind of the overall ecosystem of generative AI. And we're going to focus a lot more on large language models today, not so much on images or vision. We're going to also talk a little bit about the kind of capabilities that Abacus offers. It is a one-of-a-kind platform. It allows you to actually create applied AI systems at scale by basically having AI build the AI, right? And we'll talk a little bit about that. But before that, I'll just give you an overview of the space, how it's gone completely, crazy in terms of exploded in terms of the number of startups, the amount of interest. People like to call this the Cambrian explosion of AI, right? Basically having this space kind of impact every aspect of business, every aspect of our life already. Of course, the impact is still very tiny. So it isn't like, hey, everybody is using Gen AI to do everything, but we're beginning to see a lot of things. And it has actually started, AI is making inroads into pretty much every field in the business world, all the way from legal to human resources, to coding, to training. Of course, a lot of you, I'm sure, maybe every one of you have tried out ChatGPT. If you haven't, you definitely should. It just gives you a view, an idea of how intelligent or how smart AI is, how all-knowing it seems, how you can have a chat with it and actually, feel like you're actually talking to another human being, if not a very smart human being. So just to go very quickly through this, a lot of you are now already familiar with this. Large language models are very delightful. We're seeing a new large language model show up almost every week. Last week was phenomenal, kind of seminal in some sense, because we had the big drop from Facebook or Meta, which was Llama 2. And that is one of the, right now, considered to be the most, I would say, performant open source model out there. And that really is very enheartening for the open source AI community, because we now have something which could potentially compete with closed source models from places like OpenAI or Google and so on. Of course, we know that LLMs can be really great at generation. So it's basically generating text. If you've attended one of our conferences before, you know that simply what it's doing is just generating the next word in a sequence of words, but that's the basic way it works. There's a lot of work which has gone into LLM, refinement over the last few months, years, and we now have, I would say, over 100+ startups which are working on code LLMs, and over 10,000 startups which work on applications of it. So you're seeing this big explosion. One of the big things that everybody speaks about is the LLM does make up stuff. There have been a lot of ways in which people have tried to stop that hallucination. It's called hallucinating. It actually makes up responses. Sometimes it makes up answers. But fundamentally, what we've noted is that LLMs are really good at information retrieval. So one of the big things, at least we strongly believe, for the LLM market is going to be search. So you are going to see search, which is, by the way, a multi-trillion-dollar market, going to be very much transformed over the next few years, using LLMs. Having said that, there's a lot of other applications. We'll go through some of that for LLMs. Can be used for knowledge-based answering, can be used for summarization, can be used for extracting insights. Also, a lot of code generation types of use cases as well. So a lot of stuff going on. Every day, you see a new survey paper around LLMs. This came out last week, this particular one, which I'm referencing here. It is a very good survey paper on large language models and their evolution over the last 4 years. So if you are really getting started in this space, my recommendation for you is to read a couple of survey papers, especially if you want to go a little bit deep, going to want to know a little bit more of the technical stuff around how these things work. The origin of all this is a paper which came out, I believe, in 2014. It's a paper which is cited all over Twitter all the time. People talk about it all the time. It is called Attention is All You Need. It was from Google. 10 authors wrote it from Google. And the idea there was using the concept of neural networks, which I think most people here are probably familiar with by now, to build out a very basic language model right now, right? Which basically it kind of takes in a lot of like language data, trains itself, and tries to then kind of respond to a particular task. So think of it like, hey, if you want to ask a question and you want to get an answer, imagine if you had like a huge manual, like 1,000-page manual, and there is the answer is somewhere in there in the manual, and you need to extract that answer. What you used to typically do, and you can obviously do these with LLMs right now, is to train the model on that data, then ask the question and have it answer the question much like a human would. So after the attention is all you need paper, which was published by Google, there was an explosion of people working on that, on those neural networks, these neural networks, which are called transformers. And what you see here in this particular slide is the number of large language models which have shown up over the last 4 years. What you will see is a recurring theme on this page. You will see that Google obviously has played a really key role. Part of that is because they do have, I would say, northwards of 30-35% of all AI researchers at some point in their payroll. Of course, now a lot of them have like split out, have started doing their own startups and so on. Weirdly, Abacus, our own company, all three of us co-founders used to work at Google. So, you've got to say thank you to the company which, created so many of these large language models, also wrote the seminal paper. Of course, other than Google, we have a lot of other large big tech companies who play in this arena. We've got Facebook, which has introduced a whole bunch of models, and of course, thanks to Facebook, they've also introduced a bunch of open source models. So you will hear a lot of like conversations on Twitter around these open source models called Llama 1 and Llama 2. Llama 2 was just released last week. Again, Facebook is has been nice enough to take something which took about $20 million to train. So just to train Llama cost $20 million and open source it. Now, of course, the belief is that Llama 2 itself, not even belief, it's true, is not one of their best models. So they have, this is the last generation model. There's a lot more newer models which these companies have, which are capable of really interesting, really, compelling things. And what we're seeing already is very surprising. So you can imagine what the future looks like. So this, we also have OpenAI, Amazon, Microsoft, etc., all building out these models. The good news for the community is that it isn't just like a one place where you're going to get these models from. You are going to see it from Facebook, OpenAI, Google. You're going to see open source ones, closed source ones, and so on. And having said all this, there is a huge debate, in the industry, to some extent, in the larger kind of like arena of cybersecurity, in the arena of like national interest. So there's people in the government involved as well, as to how the evolution of these large language models is going to proceed from now. The point is we're somewhere now, kind of, I would say, on the the left-hand side of this curve, somewhere close to where the open source is fairly still like much worse than the closed source models. When we call something closed source, it means that there is an API available. Like take OpenAI, for example, we don't have access to their models. So GPT-4, GPT 3.5, the community doesn't have access to the weights. We can't go change it. We can't examine it. We don't understand exactly what's going on behind the scenes, but we do have access to their APIs. So OpenAI has made available all these APIs. You can use those APIs. You can build, applications on top of it. And you can use that platforms like Abacus really to build enterprise class applications on top of APIs from OpenAI or Google or Claude. And we can actually bring in your data from different places, use these closed source APIs, build out very interesting stuff. But the problem is that these are closed source APIs. We can't see what's going on behind the scenes. They have complete editorial control of what goes into training these LLMs. So they can decide whether, they want to only feed in the New York Times data to train the LLM or feed in Reddit plus New York Times data. So you can see how much control these closed source companies have, how much control they can exercise, and they can potentially also really censor these models. And you will see that when you use ChatGPT, if you ask it any controversial question, it might just say, hey, I'm an OpenAI, I'm an AI model, I'm not going to answer this question, I don't have an opinion, or I don't have any thoughts about this. And mostly that's because the company has trained or has really change the models, and we'll talk about how to do that in a couple of minutes, to prevent it from responding to certain questions, or basically trained it to give you kind of stock answers, which is where open source fits in. We, at least at Abacus, and I think there's a bunch of people now on the internet who really believe that this technology should be open source, and over time, this will help us actually get better at this technology. It's a very, very powerful technology. The more open it is, the more transparent it is, in some ways, the more safe it is, right? Because everybody from everywhere can really poke at it, know it, understand it, and potentially ensure that there are fewer things that that can be done which are very harmful to humanity. Traditionally, all of these LLMs have kind of grown up by brute forcing the training. So the more data you have, the better. Of course, the quality of data does matter. So the more quality data you have, the better or more performant the LLMs are going to be. So one very big kind of input into all of this is your data. What is the LLM being trained on? And if you think about it, you have to train it on basically conversations, or you have to train it on information. And most people, if it's Google, whether it's Google or OpenAI or whoever else, is looking to get as much of that data and train these LLMs on them. So if you think about who has the most amount of data in the world today, we have Facebook on one side, which has a lot of data on their platform. There's a lot of people who have conversations, they have lots of data on groups, which they can use to train models. We have Google, which also has a lot of data. Also, Google has the advantage of crawling the web. So anybody who has a website is going to let the Google crawler crawl it, right? Because we want to go and make sure that our links show up when somebody searches for things on Google. So Google has pretty much all the world's data. And OpenAI has done a fantastic job of collecting all the data that is out there as well. There's also something called Common Crawl, which is available for everybody to go and use and train this data. So there's a lot of training data out there. The problem is most people right now, the biggest and the best models actually are running out of data. So we need even more data if that's possible. So in some ways, the more data you have, and the more better quality you have, the more rosier the future of your LLM is going to be. So there's a big fight going on for data. The second piece is training. So traditionally, all these LLMs have been trained for sometimes months on end. They use thousands of computers. So you don't train them on just one or two computers. You train them on a huge army, a huge cluster of computers, 10,000, 20,000 computers sometimes. And so what's happening is, people are just buying out these computers. So you really need these graphic GPUs, unfortunately made by very few people, NVIDIA being one of the big ones. People are just basically, all these big tech companies, LLM companies, buying out GPUs by the thousands, training these models right now, and trying to beat each other in terms of which model will get better, right? So closed source models right now, GPT-4 is rumored to have trillion plus parameters. Sometimes the rumor is it's 10 trillion parameters. So these are huge models. And when we say parameters, we basically are talking about the number of nodes in that neural network, right? And this is the more bigger the model, the more memory it'll consume. The bigger the machines on which it needs to be served, the harder it is to manage. It becomes more and more of an engineering task. So if you are thinking of saying, hey, let me go, first things first, don't think of training another GPT 3.5 or 4. That's not possible to do, right? I think most people know that. There are sometimes people saying, hey, I'm going to get my own LLM or whatever. You're not going to be able to do that unless somehow you already have GPUs, and we've run out of GPUs right now. So there is this huge kind of run on GPUs almost. You can't even get a GPU today if you want to go train a model. Okay, so that is like these closed source, really large LLMs. These large LLMs are really kind of tuned also for answering kind of your generic AGI questions. So questions which you can ask it can include anything from like, hey, give me the 10 best restaurants in Paris, to like, how do I like deal with, sleeplessness? So like, how do I deal with insomnia? So you can pretty much ask anything of it. People have used it for all sorts of creative uses. You can use it as like an AI friend, a companion, a girlfriend, and so on. Then let's talk about open source models. They tend to be much smaller than closed source models, which means the number of parameters we're talking about don't tend to be in the trillions, they tend to be in the billions. The very small ones, which actually still do a decent job for some of the tasks, we're going to talk about that, could be as small as 7 billion parameters. So you can have a 7 billion parameter, 13, there's 70, there's 80, so Llama, which is the base model, this is for Llama 1. I have some, content for Llama 2 too, which just, as I said, got released last week. So there's not a lot of like work done on it yet. We're going to see a lot more work being done on Llama 2 very soon. In fact, with Abacus itself, right now we have both Llama 1 and Llama 2 available. So you could actually go use Abacus today and use these models, Llama 1, Llama 2, and actually train them or fine tune them, as we call it. We're going to talk about that a little bit, to get your own custom chat GPT as well. So open source models tend to be much smaller. They don't tend, and a lot of them are basically built on this Llama base. Again, thanks to Facebook for having outsourced it, open sourced it. We hope that other companies, especially Google or OpenAI, will do a little bit more of that. Okay, so let's just talk a little bit about the fundamental LLM. Like if you were to just need to know kind of the basics of how this works, this is a really good picture to look at. This is Llama 2 example, but pretty much all LLMs are trained in a very similar way. What you have is this pre-training data here. This is the data I spoke about. It could be Reddit, it could be New York Times, it could be pretty much any data on the web. Wikipedia is a really great one. A lot of people use Wikipedia. And you use this pre-training data and you train the first, what is called the base model. And that is the model which is almost uncensored. Think of it as a model which could potentially answer kind of really controversial questions in pretty controversial ways. I mean, I don't know if any of you remember the New York Times article which came out a few months ago, which basically talked about how the AI was on Bing. This New York Times reporter really coaxed the AI into revealing a lot more about itself. And it basically started saying that it was in love with him and, it wanted to take over and it was kind of being very evil. So this, when people say that the AI was being evil or it was in love with that person or claiming to be in love, all it's really doing, fundamentally, all it's doing is really kind of reflecting back what it was trained on. So this is the data the base model was trained on. And when, for example, if you took the Reddit corpus, so if you decided to go and take all of Reddit and train your model on that, your model is going to behave like a typical Reddit user. Reddit users are anonymous. Reddit users are lonely. Reddit users tend to maybe say a lot of incendiary things. So all the model is doing is reflecting humanity back to you, right? And of course, now you can basically start getting very religious about removing the bad data, right? Bad being what you consider bad. Again, the amount of editorial control, the amount of decision-making that goes into what is in that pre-training data itself is based on who's training it, which again, if you don't have a lot of these LLMs, if you don't have choice, if you don't have transparency, if they're not open source, it can get very dangerous. Very few people can then control these LLMs. And when they control them, they can then dictate, how humanity should behave, how to influence humanity, which can get really scary at some level. Anyway, so once the data gets pre-trained, and that's the base model, there is this very important piece, which basically is around refining that base model. The base model really can, like I said, spit out a lot of stuff. Sometimes it may not even make sense. So it might not even be good in responding to what we, to reasonable questions. So there is this kind of iteration that goes on, which is now called RLHF. There are very many, now mechanisms which are coming about where this RLHF could be potentially replaced, and we hope that'll happen. But GPT-4, for example, and 3.5 and Llama all have used this thing called RLHF, which stands for reinforcement learning based on human feedback. So the idea there is this. you basically ask it a bunch of different questions, the base model, you get a bunch of different answers, and then you have humans rate those answers. You say, hey, this is a good answer, a bad answer, or you even basically feed it good answers, right? And then now you retrain it based on that. Now, the reason why why we're using reinforcement learning is fundamentally think of reinforcement learning as basically telling the model that, if it gives you a good answer, that's a good thing. So, think of it as saying that's a +1, you get a reward for getting a good answer. And if you have a bad answer, that's a -1, you get get dinged. So you basically use this RLHF loop and keep retraining it until you get to a place where your LLM is behaving. So basically think of it as like, disciplining a kid or what have you. You've got your LLM to suddenly behave much better, be much safer. So Llama 2, which showed up last week, had a lot of RLHF in it. So they basically spent a lot of time tuning it, making it safe, responding, making sure that it's responding in a non-biased manner. Now, here is kind of the issue that most big tech companies, or here's the problem that most big tech companies face today, right? The fundamental problem is this. Let's say I said, hey, I don't want to censor too much. I'm going to just let the base model out, open source the base model. What will happen is somebody or the other is going to try a whole bunch of very dangerous questions on this base model, very biased questions, maybe, questions which are sexist, what have you, and then it'll obviously respond as per what the data it was trained on, which again, could be Facebook groups, could be Reddit, could be very, very incendiary data, right? And then you'll suddenly see the AI responding in very disturbing ways. And then everybody on Twitter and everybody else will flash mob the poor big tech, whether it's Google or Facebook, whether it's Microsoft or Facebook, and basically say, hey, your AI is racist, it's sexist, and so on. And really what's happening there, again, is the bias in the data. So what's happened, and this happened a few years ago, Microsoft, released a chatbot. They weren't thinking too much. They just released what was, trained on a standard web data. Within a day, this AI bot became supremely racist, supremely sexist, and Microsoft got into a lot of trouble. So over time, what's happened is these companies have just really clamped down. They've basically said, hey, we're going to have only these very safe, very censored, very, vanilla answers all over the place, and which is also why you're seeing a lot of these open source models as well as closed source models being really, I would say, very stock for a lot of questions. At the same time, it's really good at answering, information-based questions. It's really good at doing things like code generation. So there is just the pro and con of this. So now let's talk about what happens after a model like Llama 2 drops. So Llama 2, like I told you, dropped last week. So what happens then? What do companies like us do? What we've done, for example, is we've taken a whole array of open source models, right? And we've actually kind of trained them or fine-tune them more so. Actually, I should use the word fine-tuning, which is the right word here, for specific tasks. So now let's get into kind of the more interesting enterprise AI tasks, which, at least what Abacus plays in that world. So this is not as much as having a conversation with your AI to, hang with it or be a companion. This is more around saying, hey, how can AI be used in business? And, the various different tasks that AI can be used for include everything from generating responses to legal questions. So for example, one of the most common company, or of late, one of the most common customer that works with us are legal firms. It is amazing how lawyers have actually adopted these LLMs because they really need to extract information from all of their documents. There's a lot of obscure legal code. Now these large language models do really well when it comes to extracting these insightful questions. And then basically even constructing documents. So for example, you could construct a legal response letter from your database, have a lawyer or a paralegal review that response letter really quickly and send it off. So you can just imagine kind of the legal profession being AI assisted considerably over the next few months. The same will apply to doctors. Doctors tend to spend years learning a lot of information, right? I mean, how many of you know somebody who spent 10 years or whatever it is being a resident, like doing their MD, whatever. And most of that is cramming information. So you don't need to do that. You can get your LLM assistant to do it. And that hopefully, over time, hopefully changes these professions dramatically, that we won't have a shortage of doctors or lawyers or any other knowledge worker, right? Anyway, so the point here is, how do we do this? We do this by fine-tuning those open source models, the supervised instruction fine-tuning that is laid out here. That's what we do. And then it actually gets very customized for that particular task. Abacus can do that very easily. You can use the platform to do that. If you have a bunch of data, whether it's legal data, customer support data, technical, help, anything, name it, you can actually basically give us a corpus of data, use our array of LLMs, LLM-based models. We have some versions which are Abacus ones too, and train and fine-tune them. And here's the best part. With Abacus, you can compare. You can also use OpenAI. So you can contrast and compare. And we also will do evaluation, like how does your fine-tuned LLM. So now we fine-tuned Llama, let's say, you can actually evaluate how well it does on your particular question set. We'll talk a little bit about how evaluations of these LLMs occur, because as we get more and more LLMs, what do you want to do? You want to see which LLMs perform well, which LLMs perform badly, and so on and so forth. Now, how does that work? So there's a ton of different benchmarks. As with all I would say, early stage AI, which this is, there's always a lot of there's a lot of froth in the market, a lot of back and forth. Everybody comes up with different benchmarks, different evaluation methods, different frameworks by which you can evaluate your LLM. And right now, LLMs, today we have a whole host of them. There's Glue, OpenAI Moderator, MMLU. Now, let me tell you a little bit about how this performance works. So basically, fundamentally, what's happening is somebody will, basically, suggest an evaluation method. And I'll talk a little bit about a few evaluation methods very quickly that are there in the market. And there are a lot right now with LLMs. What is going to happen, most likely, and I hope it'll happen quickly, is that as a community, we will start kind of consolidating on a few. Here are 3 or 4 of these methods, and we're going to go with them. The ones which I like the most are the word-based ones and LLM-assisted ones. I'll talk to you a little bit about this. So here's how the word-based ones work. Imagine if you have, just say any random LLM, just think of it as a black box. And now you have, let's say, a golden set of questions and answers. So you know what the answer should be for questions. A simple one could be, who's the president of the United States? And especially if this is an AGI-based LLM, an LLM which is supposed to know all the answers, or let's say a search LLM. This is how Google actually does its search evaluations. So, you could use that as an example. You basically get your golden set. It could be the same you may have a same golden set if you're a customer. For example, one of our customers has 50 questions and they know what the answers should be. These questions are actually quite tricky. I mean, sometimes the answer is not obvious, right? The answer has to come from 3 different documents. We have to collate the answer together or what have you. So you're going to have this bunch of questions and a bunch of golden answers. And then you basically ask the LLM the same question. It outputs an answer. You're going to then see how close the original answer was, or the LLM answer was to your ground truth, the original answer. And so then you measure that closeness using some sort of a distance mechanism or some sort of how many words it has in common, how similar, how it's spaced, and then you give it a score. So all of these things which have that golden set of answers, and sometimes this will apply not just to Q&A, it'll apply to reasoning, it'll apply to a whole bunch of tasks. You can just say, here is my eval, here's my benchmark. How does this particular LLM perform on this particular benchmark? You have some way of grading those answers and you get your scores. The other really interesting thing is you can ask an LLM to fundamentally, sorry, I see somebody who's raising their hand, maybe not raise your hand and use the Q&A. Anyway, and so we can basically have an LLM assisted evaluation. And this LLM assisted evaluation basically is GPT-4, if it is considered the best LLM today, will actually evaluate the answer for you. And this is kind of fun. What basically it means is that your LLM, let's say it's Llama 2, let's say whatever it is, will respond with an answer. GPT-4 in turn will like basically decide how good the answer is. Why? Because we can basically say, hey, GPT-4 is our best available LLM today. And then now let's see how it rates the answer. So as an example of this, there is, I really recommend this site, LLMs.org. They have a lot of like really good information. For example, they devised 8 categories of different types of questions, including coding and math tasks. Now, what it has turned out to be is that LLMs can do a vast array of things. One of the most interesting things it's being able to do is code generation. One of the best models at code generation have been these GPT models, the OpenAI models, right? So what people do is they basically kind of like think about different categories of questions. They don't basically say, here's all the questions. They like actually categorize these questions. And then the idea is GPT-4 can actually even, generate those questions for you in these tasks. And then also able to like rate the questions of how good the LLM is. Like, so whether it's Llama or Alpaca or Bird or whatever it is, you can ask that question of that LLM, get a response, and then have GPT-4 rate it. And that's been a way of like evaluating LLMs. And what you see with this evaluation is really something which is very interesting. This is Llama 13B. Just so you guys know. So it's not those very big models. So when Facebook releases its models, it releases 7B, 13B, I think 60 or 70B. And this is Llama V1. So Llama V2, which is last week, I'm sure is like somewhere here now. Or here. So you see that these open source models, which are much smaller, especially for like chatting, they are as good or will become as good very quickly as at least GPT 3.5, maybe even GPT-4 over time. So we still don't have anything which matches to GPT-4. We do think Llama 2 on certain tasks, not on all, on certain tasks can be comparable to 3.5. We're going to, I guarantee you, see a lot of innovation with Llama 2 over the next few weeks. It is going to definitely catch up with 3.5, if not even surpass 3.5, I hope, on a bunch of these common tasks. So in addition to like these, kind of the chat, this one I just talked about is just like based on chatting, chatbot, language, Q&A type tasks. There's a lot of other tasks, common sense reasoning. There's lots of different benchmarks. I went through those benchmarks. Again, all of this is easily Googleable, or you can use Twitter as well. The takeaway that you need to take away from here is this, that the open source models are really coming up to speed. They're coming up to speed with the closed source models. Maybe they're not there yet, especially when it comes to GPT-4, which this table misses. But they're really kind of as good as the Google models. Palm here is from Google, as good as 3.5 and so on. And so you can definitely use them as opposed to using the closed source models, and fine tune them for your tasks. Again, these are like common standard benchmarks. Your specific task, which might apply to your specific data set, it is actually much better to have a lot of control over the LLM, which, for example, if it's an open source LLM, you do. And then it's almost much better to then use a big open source LLM and use that for your tasks so that you can actually refine your stuff. It can be more flexible. You can actually change it over time. You don't have to send the data over on the open web to OpenAI. So if you have any kind of security concerns, any kind of like, hey, I don't want to share my data with somebody, potentially can my data be used for training? Of course, OpenAI has also introduced a lot of levers where you can say, I don't want to use my data for training and so on. But open source is becoming an option, is the point. This is very quickly the Llama 2 score, which is basically Llama 2 is now coming up. I just showed you Llama 1. The point is this is straight off the presses. This report, I think, showed up 45 minutes ago. So we're going to, I mean, the open source community is going to push this higher up. In fact, Abacus is releasing some of our own fine tunes. Stay tuned for that later in the week. We have a bunch of these fine tunes. We work across the board, across various different types of open source models. Like I said, we're training some of our own models and so on. So we're going to, make a release of that. We're going to open source it as well. So stay tuned at least for that open source of fine tuning later this week. Okay, let's change tack and talk a little bit about this thing called context length. If you've attended some of our workshops and sessions, you know what this is already. Maybe most of you already know what I'm talking about here. This is really simple. Basically, when we've talked about all these LLMs, right? Now let's imagine that you want to use, let's say, GPT-4, because I've been talking about how GPT-4 is the best so far. So you are like, okay, let's use the best. Okay, fantastic. Except here's the problem. You have a knowledge base. Let's say you have a manual, which has 1,000 pages, and you have to ask questions from the manual, and you have to get responses. You want GPT-4 to do that. The GPT-4 has never seen your manual, so it doesn't know how to respond to questions from that manual. What you now need to do is to feed the manual to GPT-4. Big problem is you can't feed the 1,000-page manual. You have to feed only a section of the manual at any single time. Because at any single time, any single input response that you send to it is limited. So the largest amount you can send is 32,000 tokens, which I believe is around 40,000 words or something like that. So you can't really send really large documents. And that is the fundamental challenge that we have with LLMs right now. So once you have your trained LLM, you now have to basically only send a chunk of information. And now I think it's being the buzzword for this is retrieval augmented generation. So retrieve the right information, send it to your LLM so that it responds with relevant answers from that information. So now suddenly we have this step before we actually go off and ask the LLM any questions, which is can I retrieve the right information from my 1,000-page manual or my 10,000-page manual, send that right information to the LLM, and then get the right answer. Again, this is not a problem if the LLM was trained on that 1,000-page manual. Now imagine, Abacus offers this as well. This is basically fine-tuning based on your corpus. There are 2 types of fine-tunes you can do, just a little nuance here. One, take a base model like Llama 2. You can fine-tune it based on a particular task. So my task could be Q&A or summarization. So I can make a fine-tune just for summarizing documents. Right? This is not for summarizing a particular document. This is for summarizing documents in general. So I could then release that fine tune and say, this is a summarization fine tuner. Or I can release a Q&A fine tuner, which is really good for Q&A. Now, on top of that, I can say, hey, I want to fine tune this on my specific data, on my 1,000 pages. Turns out that that specific data fine tune is very tricky to do, not that easy. So what most people do instead is they'll take a fine tune, which is fine tuned on a task, so on a Q&A task or a summarization task, and then they will basically use this retrieval augmented generation technique, where they basically figure out which parts of the manual have the answer that you're looking for, extract those parts, and then send it to the LLM. Right? And so now suddenly you're talking about this complex, setup, right? We have first your documents, which is your manuals. It could be a lot of manuals, not just one manual. You have to take the manual, you have to process the manual. You can't just send the manual as is. You'll have to cut that manual up into chunks. You'll have to embed it. Then you're going to have to do this retrieval. You're going to have to create an index and find the right chunk of manual to send to the LLM based on your quest. So that whole thing is a whole field right now. There are another 100 companies there. I mean, there are companies which call themselves vector databases. There are database retrieval companies. There are embedding companies. There's a whole slew of stuff happening in that space, where you basically take your document, create an embedding, which is just a vector representation of your document, and then go off and create this database where you retrieve the right segment of the document to send to the LLM, if that makes sense. And then you send it to the LLM will figure out what the answer to your question is, generate the answer and send it back. So there is this whole setup which you now need, right? I'll just skip to this first and come back, which is that you have your data sources, you have data pipelines, you have to get your you'll have to do data processing, create features. In this case, you're actually creating embeddings for your document. Then you'll have to set up this document retriever. We call it document retrievers at Abacus. Those could be vector stores. Then you need to go off and create or fine-tune some of your LLMs or pick some fine-tuned LLMs. You can also use our LLM APIs into OpenAI and Claude and Google. Then you have to evaluate which LLM works well for you, given your golden set of questions. So we have model evaluation using all those fancy scores I just spoke about, and then decide which is your best document retriever, meaning the thing which retrieves that segment, an LLM combination. So it could be that you need to have a specific document retriever, which is retrieving documents in various different types of chunk sizes. So there's chunking, there's embedding, there is a retrieval, and then there's the LLM. So lots of pieces in the puzzle, right? You need to understand all of these pieces, figure this out, and then get your prediction. Not a simple problem, kind of painful in many ways. And that's where kind of Abacus comes in. You can do all this using the AI/ML platform. We have a lot of transparency. You can use any LLM API. You can use 3.5. You can use 4, GPT-4, 3.5. You can use Claude. You can use Palm, or you can use Llama. You can, you can use Llama 1. You can use Llama 2. You can fine tune it. You can create your own LLM for yourself. We can have a cluster which serves 70B Llama or a 70B Abacuna, from Abacus, and you're basically able to then decide which LLM to use, which chunking to use, which strategy to use, and you can do these experiments really quickly. This is not something where you spend months trying to figure out, here's an open source library from God knows who, try to figure out which vector database you're going to do, then figure out your document processing pipelines. We're in 2023. We don't want to do any of this. We want to be able to use, really state-of-the-art LLM and MLOps platform. We want to be able to do this really quickly. You want to be able to compare your different responses, different models, different model document retriever combinations, and you want to basically deploy the one which matters. And remember, this field is changing at the speed of light. So if you try to go and do all of this very boring stuff, if you ask me, on your own, in your cloud, you're just falling behind for all practical purposes, because there's something new which has shown up. That new LLM is not a part of this, a part of your setup. There is some new way of evaluation. That evaluation is not part of your setup. There's some way of chunking tomorrow, which people have come up with. That part is not, and all of that means your model and your answers are going to suffer. And this is a rapidly evolving field. You want to be on top of it. You want to understand it. You want to know what's going on. You want to be able to press a button and have the AI do it for you. If you're doing it on your own, you're probably going to get defunct and made defunct by the AI, right? Why is that not obvious? Somehow it's not obvious still to a lot of our people we talk to, but we'll see. You can create a custom GPT on your data, simple, easy. We suspect all the cloud vendors are going to do something like this. It's inevitable, right? You don't want to do the heavy lifting. You want a system to do it. So that's, again, what I mean by saying you need that choice. You need the various different evaluation methods. You need the different LLMs. You need the different document retrievers. Again, if you want us to do a demo, if you're part of a large company, even a small company, we're able to do a demo for you. You want a free account, you can ask for it, or we can give it to you based on, based on who you are, where you're from, because these things, a lot of them run on GPUs, they cost a lot of money. So anyway. So in a few hours, you can deploy your LLM. You can train one really quickly. With Chat LLM, you can remember context. We have citations, so you know exactly where in that manual your information was from. We have human-like responses. You can evaluate across multiple different configurations really, really quickly. And you want to be able to do that really quickly too. Okay, so that's Chat LLM. I won't go on too much about it anymore. you can see why it's really beneficial. It's also the Switzerland, right? It's not like just using OpenAI, just using Google, just using Azure or whatever. You can use all of the above, or you can use only the ones which are, not closed source. You can say, hey, I don't want my data to go out to OpenAI or Palm. I just want it to be my own fine-tuned, data. Then you can actually do that. If you are like a financial company, we work with a whole bunch of them. You don't want the data to leave your VPC. That's easy too. We'll make sure that the whole thing works within your cloud environment. Anyway, really quickly, because I'm running out of time here, I'm going to just like touch upon these little things which are over and above Chat LLM. There's this thing called AI agent. Chat LLM is mainly a chatbot. It allows you to chat with the LLM, but LLMs can be used for a lot more, like we just talked about. We can use it for grammar correction. We can use it for classification, knowledge answering, enterprise search. For that, we have something called AI agents. This is basically kind of like weaving LLMs into any particular task. So because we have a world-class AI ML platform on which you can execute any piece of code, where you can do any data transformation, you can call out to any machine learning model, whether it's a forecasting model, personalization model, you can build what is called an AI agent. These AI agents are basically kind of autonomous, almost AI agents, which will do a particular task for you. They can, for example, train a forecasting model and then tell you, summarize the forecast for the next month. So you can say, hey, go train a forecasting model, summarize my forecast, tell me where we're underperforming in terms of like my last month's results, and it'll actually do that for you on a regular basis. You can set this AI agent up to like send you reports. It can be integrated, or we're working actually on the integration with Slack and Teams, so it can be integrated into Slack and Teams. We have a connector into Confluence, so we can actually get your data from your internal Wikipedia. You can do a whole host of things. Can be done at enterprise scale, enterprise class, great security, wonderful compliance, and that sort of thing. So that's AI agents, a step above the Chat LLM when you want to do specific tasks. One of the most interesting AI agents there is what we call a data LLM. Here, we're looking at your data. So imagine if you have a database, and the database has a bunch of tables, of course, and has a bunch of data. And a lot of times, the execs have a lot of questions around the data. How many users signed up in March? How many users signed up and churned out in February? And every time you have to go off, write a report, use Tableau, use one of those really, painful enterprise dashboard thingies, get your response, build a report. Well, data LLM just lets you ask the question and gets you the answer. And that's what's really cool about it, because all you have to do is basically literally type in the question. What is happening in the background is we're setting up an AI agent, which looks at your data, understands the schema, writes the SQL query for you, executes that code either on your Snowflake instance, on BigQuery, wherever, honestly, and actually gets you the result. So it's pretty fascinating. We've seen a lot of pickup of this data LLM, one of the most popular agents we've seen. So if you're interested in kind of like creating a chat interface on your database, you've got to use a data LLM. Last piece, all of this is fantastic, but requires these building blocks. We just talked about document retrievers, LLMs, LLM APIs, all of that fun stuff, right? Prediction dashboards, integration with data sources. And honestly, these building blocks are painful, any which way you cut it. There's like, you need to have an MLOps platform. So you need to have like a world-class platform, which runs any piece of code, which does any data transformation, which does all of this. But at the end of the day, you're still orchestrating the stuff. You are data wrangling, you're pushing things to production. Now, what if you could tell an AI to do all of this? And that's AI-assisted data science. This is the next level up, where you have all of these fun goodies, but now you're going to ask an AI to build AI. Why is this possible? Very simple. We talked about how code generation is possible from LLMs. Now you can generate code to program the LLM ops and the MLOps platform. So once you have this platform, which does all this fun stuff, like set up pipelines, do data transformation, now somebody has to speak to this platform. The language the platform speaks is usually an API. Ours, of course, is an API. We have a Python API, we have a curl API, and somebody now has to talk to it. What we have is an AI bot talking to it. So now AI is building the AI. So this is a little bit meta. There's something called AI chat. It's absolutely wondrous. If time permits, or maybe in our next workshop, we do these workshops every month or so. We actually do a demo of our AI chat. Again, if you sign up, you can access it. and you can actually try it out. You can basically literally tell it to build a model. You can tell it to identify problems in your data. You can tell it to build a chat LLM, and it basically builds it for you. So it programs our system to build out all these applied AI systems. So suddenly you can build 10 or 20 models really quickly because the AI is building it for you. We've actually taken AI chat to the next level. That's coming out in the next few weeks, where the whole thing, we don't even need to tell anything, and we don't even need to tell it these things like, what are the problems with my data, or do this transformation. We can just say, hey, here's my data, go build a chat LLM end-to-end, do the evaluation, get everything done. And that's what we're calling AI, building AI. So it's one level above chat, where it chats with itself. And you will see that chat history as it chats with itself, and it builds out the full model, the end-to-end AI model. And then you can go correct the chat or tell it to stop, chatting with itself and chat in between. A lot of fun stuff there. And what we're building is what we think is all the pieces necessary to build large-scale AI agents and systems. We're really ahead of everybody else in terms of this revolution. We think this is inevitable. We also think that everybody else will follow. So you're going to not have just Abacus as your only choice. You'll have others too, but of course, we're hoping that all of this comes really quickly. So we have that inflection point where AI is really doing a lot of the heavy lifting across the board, across all these enterprises. We're an AI first world in some ways, and things are a lot more faster, quicker, and frankly speaking, a lot more fun. We do offer this sign-up token. So if you are, if you really want to try this out, this is a free sign-up token for you right now. You can actually go off and try out the Abacus platform with all of the above stuff, which it's built into it. Send us feedback or email us. Again, I have, gone over my time right now, so I'm going to stop.